Hello everyone, my name is Srinan and this is a task 1 of GRIP internship provided by Sparks Foundation. The, the task here is predict the percentage of a student based on the number of hours he studied or she studied. We imported NumPy and Pandas, NumPy for calculations and Pandas for handling the dataset, Matplotlib to uh, plot the graphs and sklearn to actually train the model. We read the CSV file into a variable and we displayed it here. There are two columns in it, one is hours and one is scores. Hours is our feature column and scores is a target column. So it basically means that a person who studied 2.5 hours scored 21 in general. It can be a percentage as well, or in general just a score. Right now we took both of the values into variables. We used min-max scaler to bring them to between 0 and 1 so that crunching numbers can be easier and the model training will be much faster. We described the error function over here, and n is the size of the training set, and it takes error as like this and it returns an error so that we can count it with the threshold later. We use train test split and 30% has test size and 0.3 determines that 30% is test and 70% is training. We update them the coefficients of the linear regression. So basically this code is going to perform linear regression on the given dataset by grip. So grad m is basically gradient descent of m and c. M is the coefficient of x and c is just a coefficient of the intercept of the line we are going to make, and then we'll change that according to the learning rate as well, which will be provided below by the user. We'll return both of the parameters and then the updation will go through all the iterations. The iterations I have concluded is 1500 and it is redundant if I increase that number because it gets flatlined and the error becomes an asymptote. Gradient descent has these parameters and error threshold, I'll explain it later. If the E is less than error threshold, then it will break immediately because we do not want our model to overfit. And then it will return, after training, it will return the final values of the M and C and the error. Using that, we can plot our graphs and we can see that the blue ones are the actual scores and the red line is what our model made, which is pretty decent for the data we have, and considering this is just linear regression, it is a good model. This you can see here that it almost becomes an asymptote over here, and here it's a perfectly parallel line, and it will go on to be a parallel line even if we increase the iterations. The mean squared error of the model is 0.0035, and this is just a scattered plot of the testing, and we can see that it is almost all near, and we can see that all this is the closest data point we have. This is a basic table to show of what our model works like. It is not very perfect, but it is still a closer look than most models. This is just a prediction function to see whether we have to test user's input, which can be random. And now finally, according to the question, if a person studies 9.25 hours, he can score 88%. Thank you.